Chapter 12, Problem number 12. A 20.0 kilogram floodlight in a park is supported at the end of a horizontal beam of negligible mass that is hinged to a pole, as shown in figure P12.12. A cable at an angle of 30.0 degrees with the beam helps to support the light. Find A, the tension in the cable, and B, the horizontal and vertical forces exerted on the beam by the pole. So our givens were that there was a 20.0 kilogram floodlight and that there was a cable at 30.0 degrees which helps to support the pole. The formulas you're going to want to use for this is that tension is equal to force times distance times sine theta minus mass times gravity times distance equals 0. And that the force of X is equal to horizontal force minus T cosine theta is equal to 0. And that force Y is equal to vertical force plus T sine theta minus mass times gravity. F being force, D distance, M mass, G gravity, H horizontal force, V vertical force, and T tension. Step number 1 is to find the tension in the cable. So you're going to want to solve for F. Plugging in your values for F times D times sine 30.0 degrees minus 20.0 kilograms times 9.80 meters per second squared times D is equal to 0. Simplifying that into force times distance times 1/2 minus 196 newtons times D is equal to 0. Adding 196 to both sides gives you force times distance times 1/2 equals 196 newtons times D. Canceling the D's out and multiplying both sides by 2 gives you force is equal to 392 newtons. Part B asks you to find the horizontal force and vertical force. Step number 1 is to find the horizontal force. You're going to solve for H. And since the force of X we know is equal to 0, this gives us the equation H minus T cosine 30.0 degrees is equal to 0. Adding T cosine 30 to both sides gives you H times T cosine 30.0 degrees. Plugging in your values for 392 newtons for T gives you the answer of 339 newtons to the right. Step 2 is to find the vertical force. Solving for V, again, F delta Y is equal to 0. Giving the equation vertical force plus tension times sine theta minus mass times gravity is equal to 0. Simplifying this equation gives you V is equal to negative tension times sine theta plus mass times gravity. Plugging in your values will give you V is equal to negative 392 newtons times sine 30 degrees plus 20.0 kilograms times 9.80 meters per second squared, giving you V is equal to negative 196 plus 196, which gives you V is equal to 0.